Alright, hi again guys. So what we're going to be working on for the next lesson is called Applying Function Notation. This lesson is probably not going to be anything particularly new. It's going to look a lot like the things we've done already, just in a few different ways. So there's going to be a couple of examples just to show the sorts of questions that you're going to see this lesson. So the first one says, the volume of a sphere of radius r is determined by the function with rule. Volume is going to be 4/3 times pi times radius cubed. What we're asked to do is state the practical domain of the function v and then find v of 10. So the first thing we need to do is state the practical domain of the function v. What we can see is that it's the volume of a sphere. So what you would expect is that the volume of a sphere, if r is the radius, it's got to be bigger than 0. Otherwise, like, it doesn't make much sense that it's like even a sphere. So what we can say is that the domain would have to be at least 0, or have to be bigger than 0. If the radius of the sphere is 0, like, there's no sphere. So the domain would have to be 0 or bigger. But in theory, it could be like an infinitely big sphere. I don't think we're considering the practicalities of the universe in terms of like how big the sphere can get. So we can just say it has to be at least 0 or bigger, or has to be bigger than 0, and it can run up to infinity. So that's basically the domain of our function v. Now the next thing we're asked to do is find the value of v10. Basically what we're asked to do is find what v would be if r, the radius, happens to be 10. So what we do is we just put a value of 10 into our function. So we're going to get 4/3 times pi times the radius cubed. If the radius is 10, then that's what we put in the radius spot. We can do a bit of cleaning up. We can say this is going to be 4/3 times pi times 10 to the power of 3, 10 times 10 times 10. That's going to be 1000. And we can clean up a bit further still. We could say that we can multiply the 4 by the 1000 to get 4000 over 3 pi. So different ways you can write that out. You could figure out exactly what number that is, but I'm just going to leave it in this sort of exact form. So that's the sort of stuff we're dealing with. I'm hoping that this is not going to seem new to anyone. It's just figuring out what domain would make sense for the function that we've got. And then the second bit is just about replacing our variable, in this case r, with a particular value. A couple questions are going to look like that. Now, that was the first bit. The second bit is sort of a different sort of question, but again, it's going to just involve using function notation. So what it says is that we've got a linear graph. We've got a domain of R, so no limitations on that. What we've got is a rule for a linear graph. It's going to be ax plus b, so it's going to be a straight line graph. And what we're told are basically there's 2 points for our graph. We're told that when x is 1, y is 7, and then when x is 5, y is going to be 19. So this is going to be, we get 2 points, so we've got to figure out the equation of the line that connects those 2 points together. It's going to involve the simultaneous equation type stuff that we've seen in the past. So the first thing I'm going to do is my rule is going to be ax plus b. I'm going to start by replacing x with 1 and y with 7. So I would get 7 equals a times x. X is going to be 1 plus b. And I can combine the a and the times 1 to turn this into 7 equals a plus b. So this is my first form of the equation. What I get when I use 1, 7 as my x and y coordinates. I can do the exact same thing with my second point, 5 and 19. So y is going to be 19 and x is going to be 5. So a times 5 plus b. And I can turn that into 19 equals 5 times a is 5a plus b, just tidying it up a bit. So I've got two equations. They both involve a and b. What I'm going to do is I'm going to label the first equation as equation 1 and the second as equation 2. Both of them have a plus b in them. So what I can do to get rid of those b's is I can take the second equation and I can subtract from it the first equation. Or I could times it by -1 and then add them together, but subtracting will accomplish the same thing. So if I'm taking away equation 1 from equation 2, the left side of my equation is going to be 19 minus 7. What I've got over here, one subtract the other, and that's going to be the left side of my equation. On the right side, I'm going to have 5a plus b being the right side of equation 2, and then I'm going to subtract from that the right side of equation 1, which is a plus b. So I'm going to subtract a, and I'm going to subtract b. So I can turn this into 19 minus 7 is 12. And then on the right side of the equation, I've got the b's cancel each other out. There's a plus b, there's a minus b. They're opposites, so they get rid of each other. I've got a 5a, I've got a minus a. 5a minus a is just going to be 4a. 12 equals 4a. I can divide by both sides by 4, and I can get out that a is just going to be equal to 3. So I've got one of my values so far. A is going to be equal to 3. To figure out what value b is going to be, I can just take either of my equations, either 1 or 2, and put in a value of a equals 3 to figure out what b would have to be. If I take equation number 1, that's got less to it, so it's probably going to make life a little easier. So I'm going to take that equation. I'm going to say that 7 is going to be equal to a plus b. If a is 3, then I can figure out pretty easily that b would have to be equal to 4. Just taking away 3 from both sides of my equation to get b equals 4. So I might just write this out. I don't have to, but it's going to make life a little easier for me. So y equals 3x plus 4. I don't really even need to do that though, because I know 2 points on my graph. I know that I've got 1, 7, and 5, 19, although my graph doesn't go up that high, so I can't really use that approach. But basically, I just need to get my graph drawn out. So what I can do is I can just figure out 2 points for my graph, 2 points that it's going to go through. The first point I might figure out is just my y-intercept. When x equals 0, y is going to be equal to 3 times 0 plus 4, so just equal to 4. So my y-intercept is going to be up here. And then any other point that I can figure out on my graph is a point that I can use. I may as well figure out the x-intercept, because why not? The x-intercept is going to be when y is equal to 0. And if y equals 0, I get 0 equals 3x plus 4. I can take away 4 from both sides of my equation, and then I can divide by 3. So I get x equal to minus 4/3, and just draw a point at about that location. And then the last thing, which is super hard on this laptop, but I've just got to try and draw a line that's going to go through them in order to get my graph drawn out. I'm just drawing my function out in that sort of way. For that Dorian's looking long, yeah. So that's basically how a few of these questions work. You just use the sort of function notation that we've seen. Basically, it's telling us a couple points that the graph is going to go through. We can replace the x and y values in our equation with those values, and then just like chug along, see if you can use some simultaneous equation type techniques to figure out the missing values that you're after. So those are going to be the 2 examples that we've got for this lesson. I did also want to add in a couple of the questions that are in the list of questions you're going to be working on, just because, no, that one's good. There were a couple of questions that are a bit trickier, and I felt they were worth going through. So first one is going to look like this. Question 4 is very similar to what we were just doing. We're told that if f is a linear function such that f of minus 5 equals minus 12 and f of 7 equals minus 6, we're asked to find f of 0 and find f of 1, and then solve the equation f of x equals 0. So basically the way I'd want to go about doing this is I'm going to use my 2 points, the minus 5, minus 12 one and the 7, 6 one, to figure out the equation of my graph. It's a linear function, it's a straight line, it's y equals ax plus b. So I can just write that out as my equation. I might write f of x equals ax plus b as my form. And what I can do is exactly what I was doing like a minute ago. I can replace f of x with minus 12, and I can replace x with minus 5. So we get a times minus 5 plus b. And then I can just clean this up a bit by saying minus 12 is going to be minus 5a plus b. That's my first point. That's minus 5 minus 12. Same deal for the second point. I can say that y would be 6 when x equals 7. So I'm going to get this as my equation, clean it up, and say that 6 equals 7a plus b. Do a similar thing to before. Here's equation 1. Here's equation 2. We can subtract one equation from the other. We can do 2 minus 1. It won't matter if we do it the other way around. It's just, I think, a little easier this way. So we'd get, probably shouldn't have an equal sign there. It's probably not the symbol to use. We would get 6 minus 12 on the left side of our equation by combining those two with each other. On the right side, we've got a plus b, and we've got one in each equation. So when we subtract them, the b's will cancel out. So we've got 7a from equation 2 minus the negative 5a from equation 1. And that's all that's going to be left when the b's are cancelled out. So on the left side of the equation, 6 minus 12 is 18. On the right side of the equation, 7a minus 5a, the two minuses make a plus. That would get us 12a. So a would just be 18 divided by 12, which comes out to 1.5. Once we've got the value of a, we can do exactly like we were doing before, take that value and put it into one of our equations. I think this one's a little bit easier. There's no negatives to it, so that makes life a bit easier. So I'm going to take that equation, replace the a in it with my 1.5 in order to figure out what b would have to be. So 6 is going to be equal to 7 times a, which is 1.5, plus b. I can turn this into 6 equals 7 times 1.5. It's going to be 10.5 plus b, and then b is going to be 10.5. Oops, sorry, wrong way around. It's going to be 6 minus 10.5, which is going to be negative 4.5. So my function is just going to be f of x equals a, which was 1.5 times x, and then minus b, which is minus 4.5. That doesn't actually answer the question. The question says, what are the values of f of 0 and f of 1? But now that we know what the function actually is, that should be pretty easy. F of 0 is just going to be what we get if we replace x with 0. So 1.5 times 0 minus 4.5. 1.5 times 0 is 0, so it would just be minus 4.5. And then f of 1 is just going to be what we get replacing x with 1. So if we do that, we get 1.5 times 1, that's 1.5, minus 4.5, so we end up with minus 3. That's basically what a is going to involve. B is basically sort of the reverse. We've got f of x equal to 0, and we have to find what x would be equal to. We know that our function is 1.5x minus 4.5. So if we set that equal to 0, we can then just solve that equation to figure out what x is going to be. We add 4.5 to both sides, so we get 1.5x equals 4.5. We divide both sides by 1.5. X is going to be 4.5 divided 1.5, which will be equal to 3. So similar kind of example to what we did before. Just got to remember these sorts of processes are involved when we're dealing with simultaneous equations. My writing gets smaller as I go on. Don't know what the deal with that is. But that was one of the questions I just wanted to go through. The other one is a bit different, which is why I felt it was worth spending a bit of time on. What we're asked to do is we're told to find the quadratic function. So this time it's going to be a quadratic we have to find, which is why it's a little different. We're given a couple of points. We're told that f of 2 is 0, and we're also told that f of 4 is 0 as well. And we're also told that 7 is the greatest value of f of x, so that's going to be where the graph peaks. It's obviously going to be like a negative 1 that peaks up at 7 in order for that to be the case. So what we should note is that if f of 2 and f of 4 are both 0, then we can figure out that our x-intercepts are going to be x equals 2 and x equals 4. They're the points where the graph is going to be 0. So that's 2 bits of information that we can use. That means our graph is going to be in the form of f of x equals x minus 2 and then x minus 4 as well. We can write it out in that particular form. We know the x-intercepts, and we know that that's how the x-intercepts get written out. So we can just write that out in that particular way. But there's the possibility that there's some value k at the front. Maybe it's 2 times whatever we just had. Maybe it's 3. I mean, it's got to be a negative number because it's a negative graph. We've just got to figure out what the value of k would be for this function. Now, to do that, the easiest way to figure this out is that we've got x-intercepts of 2 and 3. And if we remember how our parabolas work, if we've got one that looks like this and the x-intercepts at 2, sorry, we had 2 and 4, and if the graph goes up like this, we can figure out the x-coordinate of our turning point is going to be at 3, halfway between the 2 and the 4. So it's going to peak when x equals 3. So what we can say is, since we know it peaks at 7, we know it's got a turning point of 3, 7. That's a bit of information that we can just figure out. So we can figure out that it's going to have a peak of 7 when x is 3. So we can say 7 equals k, 3 minus 2 and then 3 minus 4. It goes through the points 3, 7. That's one point we can use to figure out what the value of k would be. So 7 equals k times 3 minus 2 is 1, and then times by 3 minus 4, which is minus 1. 7 equals k times minus 1, and we can figure out k equals minus 7. We're asked to write down what the function is, so the very final step would just be to write that f of x would be minus 7, x minus 2, and then x minus 4. So slightly different to what we've seen before. It's not like new techniques, but we're sort of applying them in a bit of a different way. So that's the work I'm hoping you guys will get done this lesson. Hopefully you've got those notes written down. What I'm going to get you to do is working from chapter 5F, questions 2, 3, 4, 5, 6, and 7. We've done question 5, and I think we did all of question 4 as well. So that probably leaves not too much to do. I think you got like a year level assembly this lesson, so you probably have a bit less time than normal. But the goal for this lesson is just to try and get those questions done.